Hi guys, last lesson we talked about solving equations. So in this lesson we're going to start talking about solving systems of equations. There are 3 different ways that we can solve systems of equations. We're only going to do 2 this year. The first one is solving them by graphing. So this lesson will be focusing on solving by graphing. So in order to solve a system by graphing, you're going to graph each line on the same coordinate plane, so what we did in yesterday's lesson. Then we're going to determine the solution written as an ordered pair, and then check the solution in both equations. So if we look at our first line here, we'll do this one in red. Y equals x minus 2. Just remember this part here, that's your b, that's our beginning. So we go down, and plot -2. Then our slope, there's nothing in front of our x this time, so our slope is a positive 1. So rise 1, run 1. I'm just going to kind of fill in the whole thing to help me make sure my line is straight. Remember, you want to do at least 3 points, but you can obviously do many more. Once we have all our points plotted, go ahead and connect them. Arrows on the end. Okay, so there's our first line graphed. So our second one, we'll do that here in blue. Maybe +2 is our beginning. We go up 2, plot that. Slope is -1/3, so down 1, then to the right, 1, 2, 3, down 1, 1, 2, 3, or reverse, we can go up 1 and then left 1, 2, 3. Again, at least 3 points, but you can do more. And we're going to connect them. A little off there. Arrows on the end. Okay, so there was first step, graphing each line on the same coordinate plane. Now to find your solution. Your solution to a system when graphing is where they cross. So if I highlight that there for us, then we just count it over. Our x value is 3, y value is 1. Okay, so there's your solution. Then step 3, you want to check the solution in both equations just to make sure it's true. So if we look at our red equation, so 1 equals 3 minus 2. So 1 equals 3 minus 2 is 1, so that checks out. Or if you want, smiley face. Then for the blue, 3 equals negative, oops, should plot the right, or substitute the right numbers. 1 equals -1/3 times 3 plus 2. So still 1, -1/3 times 3 is a -1 plus 2. So 1 equals 1, and that checks out. Okay, so our solution to this system of equations is 3, 1. Make sure you're writing it as an ordered pair. Alright, so work with a word problem. Amanda pays a one-time fee of $100 and a monthly fee of $10 to belong to a gym. Maria pays only a monthly fee of $20 to belong to the gym. Okay, so part A, we want to write a system of equations to represent the situation. A system of equations, if you didn't know, is when we just have more than one equation. This year we work with 2, sorry. So if we look at Amanda first, she pays a one-time fee of $100 plus a monthly fee of $10. So if we use Y for her total cost equals monthly fee, that means she's paying that every month. So 10 times X, representing her number of months, plus that one-time fee of $100. So there's our first equation. Second equation for Maria. Again, Y represents her total cost. Now she pays a monthly fee of $20. So Y equals 20 times X, where X is the number of months. And then she has no monthly fee, so it's just Y equals 20X. So we want to go ahead and make sure we define. So X is the number of months. And Y is the total cost. Okay, so if we graph these, going back to Amanda first. Her intercept, her beginning, she pays $100 no matter what. And then our slope is 10x. Now notice, each of these boxes is going up by 10, so 10, 20, 10, 20. So if we rise 10 and then run 1, notice these are 1s down at the bottom. So it looks like we're really only going 1, but our slope is actually 10. for Maria, she has no intercept, so our beginning is 0. Then her rise is 20, so up 2 boxes, right 1, up 2, right 1. Again, I'm going to go ahead and fill this in as far as I can. And then connect them. And notice this time with the arrows, with your word problem, the arrows are only on this side because they can't have a negative cost. The gym is not going to pay them. So arrows only on the positive side. But again, where do we cross? This actually helps when you continue writing your dots because you can actually see they both have a dot right there. So if we kind of follow it down, our x is 10. So solution, do that pink here, 10. Our y is 200. So there's our ordered pair. So we didn't actually ask a question here, but normally it would say after how many months would they have to pay the same cost? What would the cost be? So 10 months, $200. So we're just going to add that into the bottom here. After 10 months, spelled that. They each paid $200. So again, coming from that 10, 200. Okay, now we have some special circumstances when we're talking about solving systems of equations. So if we look at our systems, first off, if we have intersecting lines, we have one solution. They cross one time, so we have one solution. Your slopes, so your m's are different, and your y-intercepts are different. So if we have intersecting lines, that means we have different slopes and different y-intercepts. That gives us one solution. Now if we have parallel lines, we end up with no solutions. If you see here, parallel means you're running at the same rate, either rising or falling, can be positive or negative. So your slopes are the same because you have that same rise and run, but your intercepts are different. So again, parallel lines are never going to intersect, and if our solution is where they intersect, that means that there will be no solutions. Now if we have the same line, if I jump down here first, the slopes are the same, and your y-intercepts are the same. So if everything's the same, that tells us we will have infinitely many solutions. Basically, every point on the line will be a solution because they are the same exact line. Okay, so remember, intersecting lines, one solution. Parallel lines, no solutions. If they're the same line, infinitely many solutions. Those are your special cases. So we take a look at this example. Graph each line on the same coordinate plane, determine whether the solution written as an ordered pair, and then check the solution in both equations. So do different colors here again. First one in pink. So our intercept is 1. Our slope is a -1, so we go down 1, right 1, down 1, right 1. Continue that all the way to the bottom. Or rise 1, left 1. Again, I continue that all the way to the top. Make it a little easier to draw that straight line. Arrows on both ends. Okay. The second line, throw a purple in here. Y-intercept is -3, so we start at -3. Slope is again -1. So down 1, right 1, or up 1, left 1. Connect all our points. Arrows on the end. Alright, we see that we are not intersecting anywhere. It looks like they're parallel lines, which means our answer would be no solutions. But just to double check, because sometimes the solution might be off of the graph, our slopes are the same. So our answer is no solution. Now each line individually has infinitely many solutions because each point on the line is a solution for that particular equation. But together this system has no solution. Okay, that is the end of lesson 6.